On the morning of March the 7th, 1944, Vice Admiral Jizaburo Ozawa stood on the bridge of the aircraft carrier Tiho. The sun was just starting to climb over the Lingga Roads anchorage off Sumatra, illuminating a scene that should have felt like hope, but for Ozawa, it felt like a cold, hard truth. The massive ship beneath his feet, the Taiho, was the culmination of 32 months of labor, built with 16,000 tons of steel, and it carried the weight of the entire remaining hope of the Imperial Japanese Navy. The Taiho was significant because it was the only purpose-built fleet carrier Japan had managed to commission since the war against the United States had begun. One carrier in 32 months. 3 days before, Ozawa had received the intelligence reports. The numbers in those reports were so staggering, so incomprehensible, that they seemed to violate every principle of industrial capacity, shipyard limitations, and construction timelines that he understood. In that same 32-month period, the Americans had commissioned 17 new fleet carriers. 17. And that number didn't even include the smaller ones, the escort and light carriers, which they had stopped counting. Japan had spent decades building what was, in 1941, the finest carrier force in the world. They understood carrier operations better than any other navy. Their pilots were elite, their aircraft proven in combat, and their tactics refined through years of conflict in China. The Americans, supposedly, had started from almost nothing. Yet somehow, in less time than it took Japan to build the one Taiho, American shipyards were launching a new carrier every single month. Ozawa was a brilliant tactician, but he knew what those numbers meant. They meant the war was already lost. The shooting would drag on for another 16 months, and thousands more men would die. But the outcome had already been decided, not by naval battles or tactical genius, but by mathematics, steel, and welding torches in shipyards 7,000 miles away. The question that kept him awake at night was stark and simple. How did they do it? When Japan attacked Pearl Harbor in December 1941, they possessed the most powerful carrier force ever assembled. 6 fleet carriers and 2 light carriers, all modern, all battle-tested, faced off against an American Pacific fleet that had only 4 operational carriers. On paper, Japan enjoyed numerical superiority, tactical superiority, and 2 decades of developed carrier doctrine. It seemed logical to believe Japan would dominate carrier warfare for years. But paper, as we know, lies. Even before the war began, Admiral Isoroku Yamamoto understood the fundamental problem. Having served as a naval attaché in Washington, he had seen the American industrial behemoth firsthand, the vast factories, the immense shipyards, the overwhelming industrial infrastructure. The United States had an industrial capacity 10 times larger than Japan's. In raw steel production, shipyard capacity, and machine tool manufacturing, everything favored America by ratios that seemed impossible to overcome. Yamamoto warned the Japanese government that they could win battles for 6 months, perhaps a year, but after that, American industrial power would produce more than Japan could ever hope to destroy. His warnings were tragically ignored. The government believed that spirit could overcome steel, that tactical brilliance would defeat numerical superiority, and that Japan's warrior culture offered an advantage factories could not match. They were profoundly wrong. The harsh reality began to bite quickly. Japan's first carrier loss was the light carrier Shoho, sunk in the Battle of the Coral Sea on May the 7th, 1942. Significant, but not catastrophic. 1 month later, at the Battle of Midway, catastrophe struck. Japan lost 4 irreplaceable fleet carriers, Akagi, Kaga, Soryu, and Hiryu, in a battle that lasted only 6 minutes, sunk by American dive bombers. The loss was devastating. Those 4 carriers represented 20 years of Japanese naval development and 40,000 tons of irreplaceable combat power. The Japanese naval staff in Tokyo immediately began calculating replacement timelines. Akagi had taken 4 years to build, Kaga 6, Soryu 3, and Hiryu 4. The average construction time for a Japanese fleet carrier was 4¼ years. To replace 4 ships, they faced 17 years of total construction time. Japan only had 3 major shipyards capable of building fleet carriers: Yokosuka Naval Arsenal, Kure Naval Arsenal, and the Kawasaki Shipyard in Kobe. All 3 were already working at maximum capacity, building the destroyers, cruisers, submarines, and merchant ships vital to replacing combat losses and supporting offensive operations. Replacing the 4 lost carriers would require dedicating all 3 yards exclusively to carrier construction for nearly 6 years. This was an impossible choice. The war required everything, and they simply could not afford to halt all other warship construction. The compromise was to focus on 1 new fleet carrier, the Taiho, which had already been laid down before Pearl Harbor. They would rely on converting merchant ships and seaplane tenders into light carriers and design a new, smaller, cheaper class, the Onryu class, for faster mass production. It was a logical, carefully calculated plan on paper. It failed completely. The Taiho's keel was laid in July 1941. She was commissioned on March 7th, 1944, 32 months from keeling to commissioning. This was actually a notable improvement for Japan. Previous carriers like Shokaku and Zuikaku had taken 44 and 45 months, respectively. 32 months was an achievement for the Imperial Navy. But on the other side of the Pacific, the USS Essex was commissioned on December 31st, 1942. Her keel was laid just a few months before Taiho's in April 1941. Total construction time, 20 months. The Essex was larger, displacing 27,100 tons compared to Taiho's 29,300, and carried 90 aircraft compared to the Japanese carrier's 75. America had built a larger, more capable fleet carrier in 37% less time than Japan's fastest program, and that wasn't the most shocking part. The shocking part was that the Essex was just the beginning. In January 1943, the USS Lexington was commissioned, followed by Yorktown, Bunker Hill, Intrepid, Hornet, and Franklin. By December 1943, the Americans had commissioned 11 Essex-class fleet carriers, 11 in a single year. In that same year, Japan commissioned only the Taiho, 1 carrier. In 1944, the Japanese naval staff pored over the intelligence reports. They checked the numbers again and again, assuming it was inflated American propaganda. But reconnaissance aircraft, photographic intelligence, and intercepted radio traffic all confirmed the impossible. The Americans were launching carriers faster than Japan could even train pilots to fly from them. The question echoed again. How? The answer starts with a man who had never built a ship in his life before 1941. Henry Kaiser. Kaiser was a construction engineer, renowned for massive concrete projects like the Hoover Dam, the Bonneville Dam, and the Grand Coulee Dam. He saw structures, not ships. In 1941, The U.S. Maritime Commission desperately needed cargo ships, hundreds, then thousands, to ferry food, fuel, ammunition, tanks, aircraft, and troops across the Atlantic and Pacific. Traditional shipyards quoted 6 months per cargo ship. That was the standard. Lay the keel, build up with riveted steel plates, install the engine, launch the hull, and spend months finishing the interior. To build the 2,000 ships the Commission needed would take 1,000 years of shipyard capacity. Kaiser looked at the problem through the lens of a massive construction project. He saw a steel structure that could be broken down into components, prefabricated in separate facilities, and then rapidly assembled at the shipyard. His proposal was revolutionary. Instead of building ships bottom-up, one piece at a time, they would build them from large, welded sections. Traditional shipbuilders rejected the idea outright. Riveting was proven, welding was new, risky, and critics feared a welded seam could fail and break a ship in half. Kaiser accepted the risk. He built 4 massive shipyards in Richmond, California, on San Francisco Bay. He hired workers from across the country, many of whom had never seen a ship before. Many were women. Many were African Americans who had been excluded from shipyard work. Kaiser didn't care about experience. He cared about organization. He divided ship construction into standardized modules. Deck sections, bulkheads, engine rooms, and superstructures, everything was broken down into pieces. Each module was prefabricated in a separate shop, often built on its side or upside down to make welding easier. The workers only needed to know how to precisely weld that one specific piece. Once complete, massive cranes would move the modules to the shipway, lower them into position, and weld them together. The first Liberty ship Kaiser built took 196 days. The 10th took 45 days. By 1943, his yards were completing Liberty ships in an average of 42 days. The record, set by the SS Robert E. Peary in November 1942 as a publicity stunt, was 4 days, 15 hours, and 29 minutes. 4 days to build a ship that traditional builders said would take 6 months. The technique was a proven success for cargo ships, but could it work for the far more complex warship, the aircraft carrier? Kaiser proposed applying his methods to the production of escort carriers. These smaller carriers, built on merchant ship hulls, were designed for convoy, protection, and ground support. The Navy was skeptical. Carriers required specialized equipment, years of expertise, and highly trained workers. Kaiser asked for a chance. At his Vancouver, Washington shipyard, the keel for the escort carrier, Casablanca, was laid on November 3, 1942. It was launched in April 1943 and commissioned in July 1943, 8 months from keel to commissioning. The Navy wanted 50 escort carriers. Kaiser delivered 50 carriers in 14 months, 1 carrier every 8 days. The Japanese naval staff, receiving these confirmed reports, initially assumed they were errors. 1 carrier every 8 days was physically impossible. It violated every known principle of naval construction. But the intelligence reports kept coming, confirmed by American combat encounters. By late 1943, American carrier task forces were appearing in the Pacific in numbers that were tactically nonsensical: 12, 15, even 18 carriers in a single task force. Japan's entire carrier strength was only 6 ships. The Americans were deploying task forces larger than Japan's entire fleet. And it wasn't just Kaiser's escort carriers. The Essex-class fleet carriers were arriving in squadron strength. The secret to the fleet carrier speed was the same prefabrication technique. Newport News Shipbuilding in Virginia, a yard that had been building carriers since the 1930s, new carrier construction took years, but they adapted Kaiser's cargo ship methods. They began prefabricating carrier components, hull sections, hangar decks, flight decks, and island superstructures. These were all built in separate shops and then moved to the shipway for final assembly. They replaced riveting with welding wherever possible, which was faster, required less skilled labor, and created lighter structures. They standardized designs completely. Every Essex-class carrier used the same plans, the same components, and the same equipment. Workers learned to build one module and then built dozens of identical modules. They streamlined the construction sequences, building multiple sections simultaneously in different locations before bringing them together for final assembly. The USS Franklin, built at Newport News, was laid down in December 1942 and commissioned in January 1944. Total time, 13 months from keel to commissioning. That wasn't even the record. The average was 18 months. Japan's Taiho took 32 months. American shipyards were building fleet carriers twice as fast as Japan, and they were building more than twice as many. By the time the Taiho was commissioned in March 1944, the Americans had 17 Essex-class carriers in service or under construction. The ratio was worse when all types were counted. America was operating over 100 carriers of all types by mid-1944. Japan had 9. Japan did attempt to adapt. They ordered 14 Unryu-class carriers, smaller, simpler to build, and designed for mass production. These were based on a pre-war design, modernized but using proven technology. They were supposed to be Japan's answer to the Essex class. 3 were actually completed and commissioned in rapid succession: Unryu, Amagi, and Katsuragi, all within 10 weeks in late 1944. It seemed like progress. Japan was finally accelerating carrier production. Except the Americans commissioned 9 Essex-class carriers in that same 10-week period. The Japanese simply couldn't catch up. Every time they accelerated, the Americans accelerated faster. And worse, Japan was running out of resources. Building a carrier requires steel, a massive amount of steel. An Essex-class carrier needed approximately 27,000 tons of steel plate, structural steel, and armor. In 1943, the United States produced 60 million tons of steel, rising to 80 million tons in 1944. Japan, however, produced 8 million tons in 1943, falling to 6 million tons in 1944. The American steel industry was producing 10 times more steel than Japan's entire industrial capacity. This steel gap rippled through every aspect of naval construction. American shipyards had steel. They could build hulls, armor, and machinery without pause. If a section was damaged or built incorrectly, they scrapped it and built a new one. Japanese shipyards, however, had to ration steel. Every plate was precious. Mistakes had to be fixed, not replaced, and construction slowed as workers spent time repairing errors instead of moving forward. The same gap existed in machine tools. American shipyards had modern, powerful lathes, drill presses, and milling machines. Japanese shipyards had old, worn-out braking machinery, and replacement parts were scarce. It extended to welding equipment. American yards had thousands of standardized welding stations, torches, and electric arc welders. Japanese yards rationed welding equipment, often still relying on slower riveting because they simply lacked the welding capacity. The final and most critical gap was in workers. By 1943, American shipyards employed 2 million workers. Kaiser's Richmond yards alone employed 90,000 workers at peak production, more than all three of Japan's major naval shipyards combined. The American workforce was quickly trained using standardized methods. 40% of the Richmond workers were women, many of whom had never held an industrial job. They were farm wives, teachers, and office workers. They learned to weld in 2 weeks and operate a crane in 3 days. Traditional shipbuilders scoffed, arguing these workers lacked the experience for precision metal work. But Kaiser's prefabrication system didn't require years of experience. It required workers who could do one specific task repeatedly and accurately. A welder only needed to know how to weld a specific type of seam on a specific type of joint. Repetition bred expertise. After just a few months, these new workers were faster and more precise than traditional shipwrights. Japan could not replicate this model. Their shipyards, employing 300,000 skilled craftsmen, were spread thin across dozens of projects. Training new workers was slow because experienced workers were too busy. More importantly, Japanese industrial culture emphasized craftsmanship over standardization. A skilled Japanese shipfitter took pride in custom-fitting each piece to ensure perfect alignment. This approach produced beautiful, high-quality ships, but it was slow. American workers, conversely, custom-fitted nothing. Parts were manufactured to precise specifications, and they either fit or they didn't. If a part was wrong, it was simply rejected, and a new one was made. This philosophy produced functional ships, and it produced them fast. This difference in philosophy was a direct reflection of the industrial capacity gap. Japan, with limited steel and resources, could not tolerate waste, so custom fitting was a necessity. America, with abundant steel and workers, prioritized speed over perfection. The American yards could specialize their labor. One crew built bulkheads, another built deck sections, and a third installed propulsion machinery. Japanese shipyards needed generalists who could do everything. Shipfitters had to install machinery, fit hulls, and run electrical systems. Generalists were flexible, but they were slower. Newport News applied this modular approach to everything on the Essex-class carriers. They built a 500-foot-long building dedicated entirely to fabricating flight deck sections. A complete flight deck section, 120 feet by 90 feet, took 8 days from raw steel to the finished component. Using traditional methods, it would have taken 6 weeks. Elevator assemblies, complex and hydraulically powered, were built, tested, and verified in a dedicated shop before ever reaching the ship. When installation time came, massive cranes dropped the complete assembly into position, cutting the connection time from weeks to days. Propulsion systems were similarly modularized. Each Essex-class carrier needed 4 turbine sets, 8 boilers, reduction gears, and thousands of feet of steam piping. Traditionally, this took months. Newport News created propulsion module assemblies. Each module, turbine set, 2 boilers, and piping was pre-assembled, fully outfitted, tested, and verified in a separate facility. When the hull was ready, cranes lifted the entire module into the machinery space. The total installation took 3 weeks instead of 3 months. This efficiency extended to every detail. Radar systems were pre-assembled. Crew accommodations, berthing compartments with bunks, lockers, and ventilation were prefabricated and lifted into the hull. Even small items were standardized. Every hatch, door, ladder, and duct was built to fit a standard opening. Workers simply grabbed pre-made components from storage, bolted, or welded them in place, and moved on. The result? Carriers went from keel laying to launch in 6 to 8 months, followed by another 6 to 8 months for outfitting and trials. Total time, 14 to 16 months to an operational carrier. Japan could not match this pace because they lacked 3 critical elements. First, industrial infrastructure for mass production. Prefabrication required factories that could produce thousands of identical components with precision tolerances. American industry had this infrastructure from decades of producing automobiles and consumer goods. American factories were built around assembly lines and standardized, interchangeable parts. Japanese industry, conversely, had limited experience with mass production. Most manufacturing was small-scale, custom work. Replicating the American model would have required building entirely new factories, training new workforces, and developing new supply chains, a transformation Japan lacked the time, resources, or expertise for. Second, raw material capacity. Prefabrication is inherently wasteful. It requires cutting more steel than you need, scrapping parts that don't fit, and overstocking components. Kaiser's yards ordered 15% more steel than a Liberty ship required to cover waste and mistakes. This works when steel is abundant. It is impossible when steel is scarce. Japan could not afford a 15% waste margin. Every ton was precious, so waste had to be minimized, which meant custom fitting, slower work, and longer construction times. Third, transportation infrastructure. American prefabrication worked because components built anywhere in the country could be shipped to the shipyards by rail. A bulkhead section, built in Pennsylvania, could be on a flatbed rail car and arriving at Newport News within 24 hours. Japan's rail network was limited, forcing most heavy components to move by coastal shipping. That shipping was under constant devastating attack by American submarines. A turbine built in Kobe might take 2 weeks to reach Yokosuka, and if the transport was sunk, which happened regularly, the turbine was lost and had to be rebuilt. These supply chain vulnerabilities crippled Japanese naval construction more severely than any other single factor. By 1944, Japan was losing merchant shipping faster than it could be replaced. Shipyards were delayed because they were waiting for steel plate, turbine blades, or electrical cable. This forced massive design compromises. The Taiho was designed with a 160,000 shaft horsepower plant. 2 of the Unryu-class carriers, Katsuragi and Aso, had to be built with destroyer engines because the manufacturers couldn't produce fleet carrier power plants fast enough. These carriers could only make 25 knots instead of the designed 34 knots. Slower carriers meant less tactical flexibility and less ability to evade attacks. The Americans faced no such compromises. Every Essex-class carrier had identical 150,000 shaft horsepower propulsion systems, guaranteeing 33 knots. Building the carriers was only half the problem. The other half was finding the pilots to fly from them. Before the war, Japan had the best naval aviators in the world, training pilots for 2 years before their first carrier landing. By 1943, Japan didn't have 2 years. American submarine warfare was destroying merchant shipping, which meant less fuel for training flights. Training programs were slashed from 24 months to 12, then to 8. Pilots were graduating with 100 flight hours instead of 500. They could fly and shoot, but they lacked the experience to survive combat against veteran American pilots. Saburo Sakai, one of Japan's top aces, was pulled from combat in early 1943 to become an instructor. He was horrified to find the training program overwhelmed, rushed, and skipping fundamental skills. The order was simple: rush men through, forget the fine points, just teach them how to fly and shoot. These abbreviated pilots were sent to the fleet, brave, dedicated, but tragically unready. The crisis came to a head at the Battle of the Philippine Sea in June 1944. Japan committed 9 carriers with 450 aircraft against American task forces. The American fighters shot down 300 of them in what they cynically nicknamed the Great Marianas Turkey Shoot. The Japanese carriers were operating with air groups less than half the size they were designed to hold. The pilots they did have were deploying after only 6 months of training, lacking the combat experience to survive. American Task Force 58 fielded 15 carriers, 7 Essex-class, and 8 light carriers, and embarked 956 aircraft, more than twice the Japanese total. Critically, the American aircraft were superior. The F-6F Hellcat fighter could outperform the AN-6M0 in speed, dive speed, and protection. The Hellcat was armored, with pilot armor and self-sealing fuel tanks, allowing it to absorb tremendous battle damage. The Zero had no armor. A single burst of machine gun fire could ignite the fuel tank. Most critically, the American pilots were combat veterans. The average American fighter pilot in Task Force 58 had 200 hours of combat flight time. The average Japanese pilot had 20 hours of combat flight time, and some had none. The result was predictable. Japan's first strike wave of 69 aircraft was detected by American radar at 150 miles. American Hellcats intercepted them 40 miles out and shot down 42 aircraft in the first 10 minutes. The survivors ran into a second and third wave of American fighters, followed by anti-aircraft fire. Only 8 aircraft reached the carriers, scoring no hits. 4 returned to their own carriers. Japan's first strike lost 94% of its aircraft. The layered defense annihilated the subsequent strikes. Of 450 aircraft launched, 300 were shot down, and another 50 crashed, attempting to land in the dark. Japan lost 350 aircraft and their pilots in 1 day of combat. America lost 29 aircraft. That 12.1 exchange ratio reflected the cumulative advantages of superior aircraft, superior pilots, superior doctrine, and the superior industrially fueled carrier construction program. By the end of the battle, Japan had lost 3 carriers: Taiho, Shokaku, and Hiyo. The Taiho, the hope of the Japanese Navy, survived only 3 months after commissioning. Hit by a single torpedo from the submarine USS Cavalier, she was destroyed when a critical error by a damage control officer spread gasoline fumes throughout the ship. 6 hours after the torpedo hit, a spark ignited the vapor, and the explosion tore the ship apart, sinking her in minutes. 32 months to build, 3 months in service, gone. By late 1944, Japan's carrier force was effectively finished. At the Battle of Leyte Gulf in October, they committed their remaining 4 carriers as a desperate decoy force, sailing north with almost no aircraft aboard to draw the American carriers away. The plan worked tactically, American aircraft attacked and sank all four, but the sacrifice achieved nothing, as American escort carriers fought off the main Japanese surface fleet anyway. Zuikaku, the last of the 6 carriers that had attacked Pearl Harbor, went down on October 25, 1944. She was sunk because Japan no longer had the aircraft or pilots to defend her. By November 1944, Japan had no operational fleet carriers. America had 28. The American industrial advantage wasn't just in numbers. It was systemic. When an Essex-class carrier was damaged, it sailed to a naval yard for repairs completed in weeks or months, using prefabricated replacement sections. Consider the USS Franklin, hit by 2 bombs in March 1945. The bombs caused massive explosions and fires, killing 87 men, leaving the ship dead in the water and listing. Any other navy would have abandoned her. But American damage control teams fought the fires, stabilized the list, got the engines running, and the Franklin sailed to Pearl Harbor under her own power. Japan, lacking the repair facilities, the replacement parts, and the trained damage control teams, could not save heavily damaged ships. Japanese carriers hit by major attacks usually sank. The industrial gap showed up everywhere. American carriers had radar, air search radar that could detect incoming aircraft at 90 miles, and height-finding radar. Fighter directors used this radar to vector interceptors onto enemy strikes before they reached the fleet. Japanese carriers had limited radar, often unreliable, and directors had to rely on visual sighting and radio reports. American carriers had proximity-fused anti-aircraft shells. The VT fuse used a miniature radar to detect nearby aircraft and automatically detonate the shell. This increased anti-aircraft effectiveness by 5 to 10 times compared to Japan's contact and time fuses. American carriers had superior aircraft. The F-6F Hellcat could outperform the A-6M0 in almost every category: speed, climb rate, diving speed, protection, and armament. The Zero, which hadn't been significantly upgraded since 1941, was more maneuverable but slower, more fragile, and lacked the firepower to quickly destroy armored American aircraft. American carriers had better doctrine. Fighter sweeps cleared enemy airspace, and combat air patrols protected the fleet, with radar directing fighters to intercept enemy strikes early. Japanese doctrine relied on the all-out assault: launch everything, hit the enemy hard, and hope to sink carriers before they could strike back. That failed at Midway, and it failed spectacularly at the Philippine Sea. By 1945, the Japanese Navy had effectively ceased to exist as a fighting force. Without carriers for air cover, their remaining surface ships couldn't operate in areas American carrier aircraft could reach. The few remaining Japanese carriers were relegated to training or transport duties. The United States Navy had more carrier air power than every other navy in the world combined. Task Force 38, operating off Japan in July 1945, included 17 fleet carriers and 6 light carriers, embarking over 100 aircraft. Japan had exactly nothing to counter that. American carrier strikes ranged freely over Japan, neutralizing airfields, factories, ports, and naval bases. Japanese air defenses were overwhelmed, with fighters outnumbered 10 to 1 or 20 to 1. The war ended in August 1945. Japan had commissioned 6 carriers during the war. America had commissioned 20 fleet and light carriers and over 100 escort carriers. The final ratio was roughly 20 to 1. This ratio tells the story of how industrial capacity determined the outcome of the Pacific War. Japan entered the war with the finest carrier force built over 20 years by the most experienced naval architects in Asia. America entered with an untested force, built by shipyards that had to learn carrier construction on the fly. But America had the one thing Japan couldn't match: industrial capacity, raw materials, technological innovation, and the ability to learn, adapt, and scale production to impossible levels. The lesson is timeless. Industrial capacity matters more than tactical brilliance. Japan had better carrier doctrine, better pilots, and better operational experience in 1941. They won every battle for the first 6 months. But tactical advantages erode. Pilots die, aircraft become obsolete, and doctrine evolves. Industrial advantages, however, compound. Every new carrier America built made it easier to build the next one. Every trained worker made training the next worker faster. Every standardized component made the supply chain more efficient. By mid-1943, American carrier construction was a self-reinforcing system. Shipyards were completing carriers faster than they could train the crews for them. Japan never achieved that momentum. Every carrier they built consumed resources needed for the next one. The gap widened exponentially. In early 1942, Japan had 8 operational carriers. America had 3. By mid-1944, Japan had 7 operational carriers. America had 32. By early 1945, Japan had 0 operational carriers. America had 39. The progression wasn't linear. It was geometric. During the 3.5 years of war, Japan produced 9 carriers total. America produced 110 carriers in the same period. The numerical ratio was roughly 12.1, but that ratio understates the reality. American carriers were larger, carried more aircraft, had better radar, better anti-aircraft defenses, and better damage control. An Essex-class carrier could operate 90 aircraft, compared to the Unryu's 65. The 12-to-1 numerical advantage translated to roughly 20-to-1 in actual combat capability. That level of superiority made naval combat in the Pacific one-sided after mid-1944. Japanese surface forces couldn't operate in range of American carriers without being destroyed. Japanese supply lines were severed. The Pacific War became a war of American carrier aviation bombing Japan into submission while Japanese forces watched helplessly. By July 1945, American task forces operated off the Japanese coast with impunity, launching 1,000 aircraft strikes against Japanese cities. The war ended because Japan had no military capacity left to resist. Carrier aviation destroyed that capacity, and carrier production created the carrier aviation that won the war. Henry Kaiser, the dam builder who knew nothing about ships, revolutionized shipbuilding by applying mass production techniques. Newport News, the traditional carrier builder, learned from him and cut construction times in half. The Richmond shipyard workers, many of them women who had never held a wrench before 1942, built carriers in months. Together, they built a fleet that overwhelmed Japan through sheer industrial power. Admiral Yamamoto's warning was correct. American industrial power buried them, but even he underestimated the mobilization. He thought it would take America 2 years to build replacement carriers. It took 9 months. He thought American production would peak at 8 to 10 carriers a year. America produced 18 in 1943 alone. Every assumption the Japanese made about American industrial capacity was wrong. They fundamentally underestimated America's ability to mobilize resources, train workers, and produce weapons at scales Japan couldn't imagine. The essential truth remains: Japan built 6 carriers in 3 years of war. The Americans built 17 Essex-class fleet carriers, 9 Independence-class light carriers, and over 100 escort carriers. The Navy counted every ship, but the numbers became so vast that individual carriers stopped mattering strategically. By late 1944, losing an American carrier was tactically unfortunate but strategically irrelevant. Another replacement was already under construction. For Japan, losing one was a national crisis, meaning months or years of irrecoverable loss. That difference, the emotional and strategic response to carrier losses, tells everything about the industrial gap between the two nations. Industrial capacity won the Pacific War. Not courage, not sacrifice, not tactical brilliance, not warrior spirit. Steel, welding torches, and assembly lines. Wars are won in factories long before they are decided on battlefields. Vice Admiral Ozawa, standing on the Taiho's Bridge in March 1944, knew the numbers. He knew Japan had lost. But understanding the problem and solving it were two different things. Japan couldn't build more shipyards because they lacked the steel, the machine tools, the workers, and the logistics. They couldn't train more pilots because they lacked the fuel, the instructors, and the time. They couldn't increase steel production because they lacked the coal, the iron ore, and the transportation capacity. Every aspect of Japanese industrial capacity was constrained by running out of resources. Every aspect of American industrial capacity was expanding. By 1945, American shipyards were launching carriers they didn't even need. Some Essex-class carriers were completed after the war ended. Japan never built the 14 Unryu-class carriers they planned. They completed 3. The gap between American capacity and Japanese capacity wasn't small. It was absolute. The Pacific War was decided in the shipyards, not the battles. Battles determined when the war ended. Shipyards determined who would win. And the American shipyards, with their prefabrication techniques, their welding innovations, their standardized designs, and their armies of newly trained workers, crushed Japan's naval power through sheer industrial output. The Japanese built 6 carriers in 3 years of war. The Americans built 17 Essex-class fleet carriers, stopped counting escort carriers after 100, and still had enough capacity left over to build merchant ships, landing craft, and liberty ships by the thousands. That disparity, more than any battle, any strategy, or any tactical innovation, determined the outcome of the war in the Pacific.